Okay, I'm going to go over the assignments for complete the square and polynomials 1. So if you're at that point, this will be the video that I explain that. I'll also do this again in class once we get through the prep for the other assignments. Okay, so in complete the square, here's our first one. Let me switch to this so I can. It gives us a quadratic function, x squared plus 4x plus 3, and it wants us to write it in vertex form. Identify the vertex of the parabola. Okay. So what is this about? There's another form for parabolas, for quadratics. Y equals x squared plus 4x plus 3. And this represents some sort of a I guess a parabola. And it will be, let's see, I think here maybe. We'll see if I got that right. So this is the vertex. I think I got this right. At -2, -1. We'll see if I got it right by the end. And the idea is that if we can change the way this is written, this quadratic, we can get it into what's called vertex form. And in that form, it's very easy to identify where the vertex is. And then it's easy to graph the parabola. So just to go over how to do that, let me give you an illustration. Right now, I'm only going to look at the x squared plus 4x part of it. Here we have an expression that if we think about it geometrically, so we're kind of going to use geometry to rewrite the expression. And that's why we call it complete the square, because we think about it in terms of a square. You'll see that x squared. Why do we call it squared when it's raised to the second power? Well, because the area of a rectangle is the base times the height. And if those are the same, you have the same number times itself. So the area of a square with sides of length x would be x squared, or x to the second power, x times x. So if I take x times x, I would get the area of this square. So you can think of the x squared term as representing a square, the area of this enclosed in a square. So what would 4x be? Well, assuming this works even if x does equal 4. But this is a variable, so x could be sort of anything. But assuming that 4 isn't the same as x, you can let's imagine that 4 is smaller than x. Well, then this could be a rectangle, where base times height is a number times x. So this rectangle has, let's say, a height of x, but a base of 4. So this expression represents the area of these two shapes. X squared plus 4x, you could think of it as a square plus a rectangle in terms of their area, their square footage. So that's what you can think of it as representing. So what is complete the square? Well, complete the square is a method that helped us get it the expression into a vertex form, which helps us figure out where to put the dot, where to put that symmetry point on the parabola. But right now, let's think about the method of complete the square. What do we mean by complete the square? Well, we already have a square. Well, we want to turn these two shapes into what we call a perfect square. So it's not just a square and a rectangle. We want to make just one square. So what we can do is and this is always the procedure, we cut the base in half. So now I have two rectangles. I have 2 by x and 2 by x. So I've cut it in half. So I've cut the 4 in half. So now I have 2 rectangles. Well, not only is the height of the square x, so is the base. So if I take one of the parts of the rectangle, and I put it on top of the square, and then snap the other rectangle onto the side of the square, I get this. So I have my square, sort of. And then I have a rectangle here, one of the halves. And I have a rectangle here. So I've snapped them onto the square, and I've made a bigger square, almost. I'm actually missing that little chip in the corner, the chip off the old block here. So let's fill that in. Let's complete that square. Okay. So what do I have? Well, I have now the area of the big square when it's completed. Well, remember we cut this in half. So this length here along the base is now x plus 2. And the height is also x plus 2. So the area of the big square, the completed square, is x plus 2 times x plus 2, or x plus 2 squared. So x squared plus 4x, the square and the rectangle, make almost a perfect big square. I had to complete it by adding in this blue block, which actually wasn't there. That's actually extra. So if I take x plus 2 times x plus 2, if I complete this, if I make the big square, I actually overshoot the area that I originally had by the number 2. I mean, this is 2 by 2. This is a 2 by 2 little chip, little square. So I had to add 2 by 2, that's 4. I had to add 4 to this, to my original x squared plus 4x, in order to make the perfect square, the big square. So in order to make these two things equivalent, my x squared plus 4x, and I want the perfect square, I have to remember that with the perfect square, I've overshot by 2 times itself. It's always this number times itself. So even when it's negative, it's 2 times itself, or that number times itself. So in order to make these the same, I have to say minus 2 squared. So if I make the big square and then I remove the little chip, I have what I had before. So all I'm doing is rewriting what I had before as a perfect square. So I'm getting rid of the linear term, the x term. I just have a square, and then I have a number. I'm subtracting a number. So, and that's what I want. So that's the procedure. That's completed. That's what we're going to do. So whenever we have an expression and we want to get it into vertex form, what we do is we complete the square. We make a perfect square. So I'm going to rewrite this as I take x, and then I always put half of this number here, and I get the perfect square. Then I have to subtract this number squared. Whatever I got here, I have to square it, and I have to subtract it. Now this is the same as what I just wrote. But remember, I still have that plus 3. So I have this, that's equivalent, and I still have that plus 3. And that's the procedure. You just have what's the x term is, make the perfect square, subtract whatever that new number is squared, and don't forget that you still have that constant hanging out this right side. All right, so to rewrite that, I have y is equal to the perfect square. And then if I combine these constant terms here, minus 4 plus 3 makes minus 1. That's vertex form. That's officially vertex form. Now, I kind of like to think of vertex form a slightly different way, but the questions that you're going to answer all want it like this. But I'm also going to show you it in a slightly different way. So I'll do that in, I guess, green. If I add 1 to both sides, so I get the perfect square all by itself, I'll have y plus 1 equals to x plus 2 squared. This is pretty much vertex form. I would prefer this if this were called vertex form, to be honest. But no textbook and no question bank is going to call that vertex form. They're going to call what we had just the line before vertex form. The reason I like this way is because x and y are then symmetrical. They work the same. So all I have to do is take the opposite of the number that's added to y, so minus 1 instead of plus 1. And I take the opposite of x, and I get minus 2 instead of plus 2. That's the vertex. X goes first, minus 2, then y, minus 1. There's your vertex. I like that because you take the opposite in both cases. X and y work the same. They're not different. It makes sense when you put the y number on the same side of the equation as y, just as the x number is on the same side of the equation as x. Then the rules are the same for x and y. But unfortunately, everyone in the world likes to keep y's translational number on the other side of the equation from y, whereas x's is on the same side of the equation as y. So you have to remember that x and y work oppositely in that case, in vertex form. So in the version that I prefer, they work the same. Take the opposite, and that's the vertex in both cases. But for vertex form, you take the opposite of the x value, so minus 2. But you keep this exactly as it is, so minus 1. So this one's the opposite. This one's as is. But it's pretty much the same thing. So completing the square puts the expression. So if I saw x squared plus 4x plus 3, I wouldn't know where to draw the vertex. I wouldn't know where exactly this parabola starts. But if we do this complete the square method, we get it in what's called vertex form, and then it's very easy to see where the point of symmetry is. You just take the opposite of the number added to x in the perfect square. That'd be minus 2. And then you take this number as the y translational amount, minus 1, and that's the vertex. So that's what they want for that question. And that's what completing the square does for you. So complete the square, write the quadratic in vertex form. You get x plus 2 squared minus 1. You do that by completing the square. Identify the vertex of the parabola, take the opposite of x, so minus 2, and take that as is, minus 1, and you get the vertex. So that's what you got to do there. So we'll do another one, just to practice. Okay, so now this one is y is equal to x squared minus 2x minus 3. All right, so we're going to make the perfect square. X, take half of this, minus 1. We have that extra chip in the corner, and I'll go through the perfect square thing and again for this one in a second, but just to go through the procedure, take half of this number, put it there, make the perfect square, and then remember to subtract, always subtract the square of this number. Now this number happens to be -1, but -1 squared, -1 times -1 is 1, is positive 1. We have to subtract that positive 1. So even though it's a minus, when you square it, it makes a positive. So to subtract its square means we have to subtract, it's always going to be a minus here. So -1, and then we still have the minus. So this is equivalent to this, but we still have the -3 to worry about. All right, to finish it off, y is equal to x minus 1 squared, and then -1 and -3 make -4. The vertex is at, take the opposite of the x number. So opposite, and then as is. So we're going to say 1, and then we're going to say -4. This is vertex form. This is the vertex. So if I had my parabola graphed, it would be at 1, -4. So it's a sloppy drawing. All right, so I'm going to walk through again how we took x squared minus 2x and think of it like how we did with the squares. So I have an x by x square, and then I have an x by -2 rectangle. So that may be confusing. How do you have a height of -2? All I'm going to say is that when we think of like a coordinate system, and if I think of like 1 by 2, and let's say that's my square, we would say this is 1 by 2. So this is area of 2. But let's say it was like this. I'll say 1 by 2, area is 2. But let's say I have it like -1 by 2. My area is now -2. What does that mean? How can you have an area of -2? All you got to do is think about it. It's directional. Negatives are always directional. So we have what's kind of called the right-hand rule. You'll probably hear about it from time to time. Basically, you take your thumb and you point it along the x, and then you take your fingers and point it along the y, and that the face of that's the direction of the plane. So that in the first case, I have a one, my 1 goes to the right, my 2 goes up, so my rectangle is pointing up. So, but in the other case, my thumb goes left, and then my fingers go up, and so my rectangle is pointing down. So when we talk about like a negative area, or you have a negative number, just think of it as the thing's flipped over. That's all that's all it is. Don't overthink it. So it's okay. You can do the same thing when it's a negative or when it's a positive height. It still works the same. You'll still cut it. You'll still make this box, sort of. And you still have to remove this little chip in the corner. So that's what we did. We halved the -2 to make the perfect square. That was a little too big. We had to remove that chip in the corner, which was an area of 1. So we took -1 onto that perfect square to make it equivalent to what we had before, the x squared minus 2x. We still had the -3 We cleaned it up a little. We got vertex form. Then the rule, the opposite of the number on x, the same as this number for the y. And then you have vertex form. And then you know where the vertex is. It's at 1 comma negative 4. So it works when it's a positive number on the x and when it's a negative number on the x. It might seem confusing when you think about it geometrically, but if you think about geometry with a coordinate system, then it's really just kind of like which way is the rectangle facing? Is it face up or is it face down? That's what we mean by negative area. All right, so for this one, you'll see that we have half of the 2 to make the perfect square. And then we have to subtract 1. And so minus 1 and minus 3 make the minus 4. There's our vertex form. Notice they already have the y equals, so you don't have to put that in your answer. Identify the vertex of the parabola. Well, it's the opposite of this, 1 comma negative 4. And that's it. For this one, okay, half of negative 6, so we're going to have x minus 3 squared. And we have to subtract minus 3 squared. So we're going to have a minus 9, and minus 9 plus 5 makes minus 4. So we're going to have x minus 3 squared minus 4. And then the vertex will be at 3 comma negative 4. Hopefully that's not too bad. This one, half of the 6 makes x minus 3 squared. Again, minus 9 and a plus 5 make a minus 4. So is that the same? That's the same. You got the same question twice. And so the vertex is the same. Okay. Okay, so this one they set equal to 0. So we can solve it. So we're going to complete the square on the x squared plus 8x part. So that's going to be x plus 4 squared. Then we have to subtract 4 squared, so that's 16. So minus 16 and minus 20 make minus 36. They want it on the other side, so it's going to be a positive when I add 36 to both sides. So we're going to have x plus 4 squared equals 36. And to solve it, you can square root this to get x plus 4. I'll do this part on the writing. X plus 4 squared equals 36. Actually, I'll do the whole thing. What do we have? X squared plus 8x minus 20. So half of the 8 minus the 4 squared. Keep the minus 20. This is equals 0. Okay, so this makes a minus 36. And they want this on the other side, so that's what we got to. Now they want the solutions. So I'm just going to square root both sides. I get x plus 4 is equal to plus or minus square root of 36 is 6. So I have x is equal to minus 4 plus or minus 6. So one of my answers will be negative 4 plus 6, that's 2. And one of my answers will be negative 4 minus 6, that's minus 10. So those are my two answers, 2 and minus 10. So yeah, I just separate it with a comma. Here's another one we've got to solve. I'll do that one real quick. X squared minus 4x minus 5 equals 0. Okay, have the 4, subtract the square, keep the minus 5. Okay, so that's x minus 2 squared minus 9. I put the 9 on the other side. Square root both sides. And then you get x is equal to 2 plus or minus 3. So that means it's either 2 plus 3, which is 5, or 2 minus 3, which is minus 1. So let's see if we got those right. So yeah, that's half of the 4. There we go. And we get the minus 4 and minus 5. So we get the minus 9, put it on the other side. Square root both sides, you get 2 plus or minus 3. That should give us 5 or minus 1. This is the same. I'll remove this question, number 8. Oh, wait, no. No, I do want those. I do want those. All right, so number 8's a little different. So let's do that. Let me go to number 8 here. Okay, this one's a little different. You have 2x squared, so this complicates things at 2. Plus 4x plus 2 is equal to 0. Okay, so now when we have an x squared plus something x, we know how to do that now. You just have it, subtract the square of the halved number. When you have a number like 2, you just want to factor it out. So I'm going to put a 2 here, and if I take a 2 out of this, I have x squared. And if I take a 2 out of this, I have 2x. And I'm just going to take it out of here. You could take it out of here, I guess, but I'm not going to. I'm just going to leave it like this. So now, in parentheses, I have something that I can complete the square on. So I'm going to say 2 is equal to, and now this will be the same as what's in parentheses. I'll have x plus 1 squared minus 1. So I have the 2, and I subtracted the square of that new number, which is 1. 1 squared is 1. I still have the plus 2 equals 0. So all you got to do is factor out a 2 from the x squared and the x term, and then just do what you did before. All right, so now we'll move the 2 over. We'll divide by 2 on both sides. And now we're kind of where we're used to being. Because this cancels and makes minus 1. All right, add 1 to both sides. Okay, you get x squared plus 1 x, sorry. Let me erase that. Add 1 to both sides. It becomes 0, actually. Square root both sides. Square root of 0 is 0. So x is equal to, I guess it's plus or minus 0. And then you get minus 1 plus or minus 0. So you actually have 2 answers, technically. But this is called a double root. So I have minus 1 plus 0. And I have minus 1 minus 0. So you get the same answer twice because this other side was 0. That means you have minus 1 with a multiplicity of 2. And that's meaningful, so you don't want to forget that. Let's see. They just want you to write it once, so I guess they don't care. Okay, here you have a minus. If I factor out the minus, let's see, minus x squared plus 2x minus 1 equals 0. We're going to factor out the minus sign. So if I pull the minus out of here, I get x squared. If I pull a minus out of here, I actually have minus 2x. It just changes the sign. All right, now I'm going to complete the square inside the brackets. It's minus 1 squared minus 1. And then I'm going to add 1 to both sides. Divide by -1. That just moves the negative over here. Add 1 to both sides. So we're going to get a double root again. Square root both sides. And then you get x is equal to 1 plus or minus 0. That means you have 1 twice. And they probably just want you to write 1. Yep. All right, we'll do another one of these just to give you practice. Uh, 3x squared. Sorry, I got to click. Plus 30x plus 75 equals 0. I guess another thing you could do is just divide everything by 3. Well, every term by 3, I guess. And that might be easier than factoring out. So this becomes that, this becomes 10, this becomes 25, and this still 0. So now you get x squared plus 10x plus 25 equals 0. That's another thing you could do. So now I get x plus 5 squared minus 25 plus 25 equals 0. These cancel. So I have x plus 5 squared equals 0. Square root both sides. X plus 5 is equal to plus or minus 0. So that means that x is equal to minus 5 twice. Yeah, okay. And this you could do the same. You could divide everything by 2 and turn it into x squared plus 2x plus 1 equals 0, and then solve that. Which, let's see. So x squared plus 2x, to complete the square, you take half. So this is going to be, again, you're going to get a double root. Okay. Well, let's complete the square. I might just leave it there and do the polynomial one in the next video. Hope that helped.